we are going to take the opportunity to talk about inverse trigonometric functions. We will see these will be useful when we do our homework. This is just going to be a very basic intro into the relationship of inverse trigonometric functions. I want to take a moment to remind you that when we went through summer homework, we talked about function machines. Remember, there was a domain that had an x in it. We went to that domain, we picked up the x, we put it into a function machine that was some sort of manipulation on that independent variable. The manipulation was done on the independent variable and it resulted in a range value. For us now, our functions are going to look like sine and cosine and tangent and so forth. That's what our function machines are doing. If I take all of these range values, all of those y values, and I now force this to be the domain of another function, if I feed that into a function machine that reverses the operation, there's inverse, remember the little superscript negative in this case doesn't mean reciprocal, it means inverse. It reverses the operation that was done on the original domain value. Then what must come out over here, what has to, since it undoes the operation that was done here, what has to come out is the original independent variable that I started with. But now that whole set is going to be the range of the inverse function. Because the domain and range of a set of inverse functions are switched, it is the reason why the graphs of inverse functions are mirror images of themselves over the line x equal y or y equals x in the plane. Because we're reversing inputs and outputs, I want to talk about undoing a trig operation. In general, I want you to see that all domain values, the set in the domain of any trig function, are angle measures. We take the sine, the cosine, the tan, the cotan, the cosecant, and we put an angle measure into that function operation, and the result that we get out is a ratio of lengths of two sides of a triangle. Those are all the values that show up in the range of our trigonometric functions. So when we reverse or invert those operations, it should make sense. Give myself a little more space here so we can do kind of the same thing that I just did in general. If my domain values are angle measures, and I have a trig operation happening, then the resultant range values are some ratio, y over r, x over r, y over x, and so forth. So if I force those values to be the domain of an inverse operation, this operation reverses whatever operation was done here, then I'm going to pick up a ratio. I'm going to plug it into this function machine, and the result, the outputs of that inverse function, should be an angle measure. And notice that is what's happening here. If I take the sine of theta and I get the ratio y over r, then when I reverse that operation, when I pick up that original range value and force it to be the domain of the inverse function, then the result that I should get out of that was my original input value, my original domain value. So the same is true for trig functions, just as it is any algebraic function. So we recognize that the sine of 45 degrees is root 2 over 2. So specifically, for the sine inverse function, we should be able to tell that the sine inverse of root 2 over 2 is 45 degrees. Be very careful for statements that look like that. That is not a true statement. The domain values for any inverse trig function should not be an angle measure. The range values for any inverse trig function should not be a ratio. So be very careful. This is saying that if I feed the sine function its inverse, those two things, those two operations undo each other. And no matter what I have in here, it maps me back to where I started. Here I started with the inverse function and found an angle measure. And then I plugged that angle measure into the sine function. And those two operations undo each other, and it maps me back to the original domain value, which for inverse was the ratio. If I take the sine inverse and feed it something, I should feed it a ratio. Well, it is true that the sine of theta is a ratio. I just fed it the equivalent of that ratio. And if that's the case, when I feed the inverse function that ratio, it gives me my angle measure that I started with back. And that's why it feels like you want to say, hey, those two things just cancel. No. This is taking you completely through the domain to the range of the original function, and from the new domain of the inverse function back to the new range of the inverse function, which maps you back to your original input value, your independent variable value. Let's look at all of the inverse functions and all of the domain and range pairs for the pairs of inverse functions. If I feed sine and angle measure, I get a side ratio, specifically of opposite over hypotenuse, as a result. The domain for the sine function, all real numbers, the range, -1 to 1. For the sine inverse function, the inputs to that inverse function have to be the outputs to the sine function. So the sine inverse of a side ratio gives me an angle measure. The sine inverse of a range value maps me back to a domain value. Notice the domain and range of those pair of inverse functions are reversed. Be careful not to just memorize in one direction. These relationships go in both directions, as I just showed you on the previous slide. I can take the sine of the sine inverse as easily as I can take the sine inverse of the sine. Notice that carries forward for cosine, angle measure, side ratio, cosine inverse, inputs of side ratio, outputs of angle measure. Domain, all real numbers. Range, all real numbers. Range, -1 to 1. Domain, -1 to 1. And very quickly, just on that center portion of the tangent function that we concentrate on, remember, there are infinitely many pieces to the domain of tangent, but we still feed an angle measure, get a side ratio. So in the inverse, we have inputs of side ratios, outputs of angle measures. The domain of tan matches the range of tan inverse. The range of tan matches the domain of tan inverse. These pairs of functions undo each other. They reverse the mathematical operation that was done to the original domain value. So there we are. This is exact values. Come to class next time and we'll work some homework problems with your angle measures being in degrees.